collaboration in business analytics. Thank you. Let's put our hands together to welcome him. Thank you.
All right, thank you very much. So yeah, my name's Rich. I'm here to talk about reproducibility and collaboration in sort of a business context. So as a bit of an overview, sort of going to give an introduction both to myself and then sort of look at what reproducibility is and why does it actually matter in both a sort of academic and business context and why we do what we do. Looking at some ways that we can try and improve reproducibility in the work that we do, and then sort of pivoting from that into a piece around collaboration within business and academic environments with people utilising different tools and making sure that they're all on the same page in what they do. So a couple of disclaimers. So whilst I am a sort of data scientist or machine learning engineer, this talk is focused more on the sort of grittier side of business analytics. It's stuff that generally comes from a lot of people using Excel that you see in large businesses, rather than the shiny side of stuff that they try and portray that they do. And the second one, I guess, follows from, I'm not overly a Python developer. I've been sort of learning for the last 3 months. I very much enjoy it, and this talk sort of borrows partly from R, which is my previous language, and comes towards that in the collaboration aspects. But everything you see in here has a Python integration as part of it. So, as my background, I was a scientist, so I have a degree in biology, I have a PhD in molecular biology. I used to work on plant-parasite interactions, so that used to be my big bunker of rice that I used to grow. And as you've also probably heard this weekend, there's a lot of inherent reproducibility issues within science. From there, I sold my soul and moved into business as a consultant for PricewaterhouseCoopers, where I worked in quite a lot of large businesses, focusing around analytics and the sort of logic they use for business processes. So amongst those are sort of big rail companies, large pharma, pan-European distributors, things like that. And I've since pivoted into working into analytics, so I started as a data scientist for a large retail organisation, and now I'm back doing analytics, but as a consultant. So what is reproducibility? So again, as we've heard from some of the stuff this weekend, reproducibility basically is, in essence, having the same data, the same question, the same hypothesis, doing everything the same way, and the data being produced in by the same person. However, the actual analysis will be produced by someone different. So imagine having exactly the same data set with the same code, but that being run by 2 different people, possibly in 2 different settings. And how do you actually get issues in reproducibility? The main one that you see in business is people leave. So people move around all the time, especially in tech. They go somewhere else for whatever reason they have, and they leave a process that they have inherently known themselves, know the intricacies of, and that has to be then picked up by someone else who probably doesn't understand it as well as them, and that leads to massive issues in making sure that still works. Again, it's lesser extent, but people move internally within the business. You might move from, say, a finance function to something else, and then you can't find the time to pull those people back in to explain how something works, and it will break. Or if you're dealing with things that aren't stored in databases or immutable, people tend to mess with data. So you might pull a load of data from a load of CSVs. People will put their own overlays into certain aspects of those because they think, oh, that number's not right for me, or this one's there, and then so that changes results from month on month. And why does reproducibility matter? So this is a diagram from a journal called Nature. So it's one of the highest impact journals in science in the world, and they did a survey of around 1,500 researchers and basically asked, do you think there is a reproducibility crisis within science? And as you can see, about 90% of them agreed that there was, and that they need to sort of try and rectify this. So moving on to that. Why does it matter in that context? Because getting the same answer to the same question is really important. If you do A plus B and it equals C on Monday, and you do A plus B on Wednesday and it equals D, something's going wrong. And that change in answer leads to a lack of confidence in the results that you're putting out. And in a business context where you might be doing a forecast or some sort of model that people rely on to do things, if those results are changing day on day, week on week, when you run it from whenever to whenever, you're going to lose confidence, and people are really going to start questioning what you do, which can heavily impact the efficiency in which you do your work. So if you present something to a board and suddenly something changes and like, why does this change? You're going to have to do a massive deep dive into what it might be in your code or your specific piece of analysis that actually leads to this, which means you're probably going to have to either do that in your own time or stop doing your day-to-day work to go and figure this out, why you've made this bug, why this error has appeared. And it may not be anything to do with you, it may be a process piece, maybe something from the wider business, but it can be really damaging both to your confidence, to people's confidence in you, and the actual work that you do. So, I'm going to first off try and explain a few ways in which I've found over my career that you can really try and improve reproducibility within an academic or a business environment. And the things I'm going to discuss aren't fancy, but from what I've seen across my last 3 years or so, they're things that are quite or people don't do to enough prevalence and can have serious impact on things. So the first one is properly structuring a piece of analysis. So you want to set up a folder structure that allows everything you need to be in one place. So when you build a web app, for example, you build it all in one file, you have your modular sets and things call from another, and it works. And then that, when you transfer it somewhere else, will then work. The same should be done for a piece of analysis, whether you're doing bits in Excel, you're doing bits in a particular coding language, whatever you're doing it in, you should set it up as you have a main working directory with a set folder, and then within that you keep all the data that you need, all the outputs, all the documentation that might go around it, so you might use specific functions or things, packages that you call, so you might have to bring documents and things like that, any figure outputs that you put in, and also the scripts that you run. And this just allows you to package things up properly, so say I did a specific piece of analysis for some sort of forecasting, I left the business to go do something else, and then I can give this to someone else to just run over and over again, and in theory it should work. And there are reasons internally why this might not work, which I'll come into again. And examples of this going wrong I've seen is mostly people pulling data from local sources but varying across different folders, so that you really can't replicate that just in the structure that you have. So setting relative paths, and this is more specific to coding languages, and the bottom piece is a joke that, whilst it's an R joke, it sort of applies to everything. In that I've seen a lot of scripts over my time where people just set off a set working directory, which means as soon as you transfer that to someone else's computer, that's never going to work. And it becomes a real pain when you spend an hour trying to debug someone's code, and then you realise the first line is where it's all gone wrong. So setting relative paths, so there's packages in both R and Python that can really help you do that. And it means, in combination with that folder structure, you're going to have something that you can pass on to someone else, and they can run again and again and again. And it just makes people's lives easier. It comes back to that efficiency piece. So I don't know if anyone enjoys these fake O'Reilly books, but I'm quite a fan. So a big piece on it is building understandable code. So it sort of comes down to this piece around code smells and feels, which, if you come across it, it's sort of a philosophy of how you might refactor your code or how you build your code, in that when you start out, you read other people's code to learn things, and you see a specific style, and sometimes you see code and you think, that looks really good, I want to try and emulate that, I want really good, and you see other pieces and you go, definitely not, stay away from that. However, people's taste develops a lot faster than their ability. I know I can read a lot of really good Python that I struggle to replicate in certain logics just because I don't know it that well yet, and the same in R. So you sort of, as you develop, you need to sort of learn to refactor things that you've done in the past so that they still make sense and they work in the most efficient way. You might build something the first time that gets the job done but is a bit messy. A year later you come back to it and go, oh god, that looks awful. Overwrite it, test it, make sure it does the same thing, but it helps. Utilising code comments for business logic, so you should be writing code in a way that the code itself can speak for what it's doing, so what its particular function does, but you might use particular constants or particular methodology that's wanted in a business context. Someone else's, if you give that to someone else who doesn't have that context, they're never going to be able to understand that without commenting those pieces in, and they're the sort of more important things to include. And this sort of comes back to the folder structures and making everything modular. So you utilize functions, put them in a certain package that you might produce, and then call that in and put that within your structures. And doing this gives you a set of maintainable, readable, reusable code, which is really important in a reproducibility context. So another piece is, this will flick through again, is sort of how you package up the products and how you utilize them. So Docker has become really interesting over the last 5-10 years or whatever, of producing containers that people can run either locally or in the cloud with a set environment, a set of functions, set of data, etc., pulling in maybe from cloud sources, maybe from not, and producing a set output. And something I've sort of come across quite recently is this program called Binder, which will take a Docker image that you give it and produce a cloud-based example of that analysis. So fair enough, your analysis might be something that's very specific to that business or has sensitivity issues, and you can make a reproducible example of something that you do, put it into a container, put it up in the cloud, give someone a link, and they can see how it works. They can play with it, test it, break it, see what goes wrong. And the example that's sort of floating around here is a really interesting one that they've just done with the latest scikit-learn, where every function in this should link off to a binder, or if you click the bottom you can get a binder, basically cloud workbook, to go and test the things that are in scikit-learn. So then you can go and break it and see how it works and understand it better. Right, so moving on from improving reproducibility, there's collaboration. So it's a really important piece in business or any context really, that you have, generally you have technical analysts and you have business analysts or project managers or people who understand the business or where a particular project is going, and you have someone technical who's doing the underlying work and producing the figures or the answers. And they need to be able to work together effectively. And it's unlikely that you're going to be using the same tools. I've never met a project manager that writes Python or does Python for their day-to-day job, or writes in any coding language generally, and the same you get from business analysts. And you sort of get this thing which a guy from the States called Noam Ross has characterized as the valley of heartbreak, where you try and meet in the middle, and it's quite hard for tools to go one way and back again. So it's quite easy to go from, say, a coding language into a Word document or to Excel or to a PowerPoint, but actually pivoting that back so that the changes can be reintroduced into that coding environment are quite difficult. So why not just hammer? Why not make everyone use the same tool? Because people like their tools, they spend their time learning them, and this sort of thing has come from some recent stuff on Twitter, this sort of location thing going on about people having spats over it, saying, well, every place has their place. And in this, people have their languages, they use them for certain reasons, they use their tools for certain reasons, they spend time learning them, and yeah, stuck an R joke in it, because I'm at a Python conference, that's bullying on. And so, with that though, there are inherent problems in the current ways of working. So I haven't put slides on here, but you can quite easily go from a coding environment into, say, like a Beamer presentation, or iSlides, or a PDF, or slides, which is what this is. But you can go between a coding environment and Excel quite easily. There's lots of packages for reading Excel, writing CSVs, reading back in. That we've got down. The main issue I sort of found is report writing, where you would write a Jupyter notebook, you would write a markdown document, you would do something, you would then save that as a PDF, email it to someone, they would then print it, scribble over it, give it back to you, and then you would go and type up everything they've written, usually out of context, or you might can't read their writing, they might have done something wrong, etc., etc. And you end up in this big cycle of just sending them something, printing something off, going round and round and round. It's not particularly fun. So is there a sort of potential solution to this? And I have taken the risk of doing a sort of live demo, which will probably go horribly wrong. So this is, please don't cry, this is our studio. So I've written, basically, it's just a markdown document, basically, with a bit of code, so I'm just loading some data in, building a plot, and then utilizing Python to then take some data from that, run a quick linear model, then pull out the R² value, and then what you can do is you can use a package that is available in R and I believe is being ported over quite quickly into running in Jupyter. So obviously that's a good environment for using both Python and R, other things together. You can knit this out into a Word document. So if I click this button here, I would end up with this document. So you can do stuff to ignore all this, and then basically this gives you out with the text that you have, and then you can add. So you could send this off, email this off to a business analyst to go, why do you use this? Da, 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 da. And then, or you might want to say, so one of the annoying things I always found was company colour schemes. Change this to X, Y, whatever. So you can hand that off to them, they can work with it, they can then save it back. So, providing this works. Save it down, send it back to you. There's no printing, there's no PDFs, there's no scrolling on things. They can write in the logic that they need to write, and you can, whilst they're doing that, you can be doing another piece of analysis, saving you a bit of time. And then all you have to do is read it back in. Sorry. So, right, this works. There you go. So you can read it back in. It will give you, so I haven't got my folder structure up, but here, so you end up with basically a coded version of that, which you're already working in, and what you can do is look at an actual viewer of seeing where you might have, so it's highlighted the differences that someone else has written into that, and then you can stand that. So if they've added a comment saying, oh, we don't like the colour blue, we want it to be red, you can then go away, change your line of code very easily, and sort it. So that's just an example. I'm not penning this as the final solution, but it's interesting to see that people are building these tools out there to help collaborate in this way. And that's it.
Thank you very much, Rich. I'm pleased to say it's time for questions. Please remember that a question is a question. Thank you. Yes.
Hi, thanks for the talk. Quick point. You were just showing there in the live demo and the fact that we've got two parties then able to change a single document. I'm just interested to know, are you also using version control on that as well, so that if somebody does something slightly unusual, in inverted commas, to your code, you can then wind it back a bit and say, well, if you look at, so you can actually sort of like pull it back to a previous version if there's miscommunication or anything.
So I haven't looked at anything in terms of introducing it with Git, but you could use sort of standard business stuff where you just version it and add incremental numbers to it, and then you could put that in a Git repo, and then so every time, so when I load that Word document back, as long as someone has not called it the same name, it will make a new file with that name in it. So say someone had changed something fundamentally wrong in that next Word version, I could just go back to my earlier markdown document and then utilize that. It doesn't overwrite anything, and then if you want to, you could put that into a Git repo and make it a private repo and work between there.
But that might be an idea though, just to say, so that you could actually do it, so then you can just forward one, rewind without having to go into the hell that is having multiple documents with slightly different numbered things, and people forget what number they're supposed to be at.
It's a very interesting piece. I mean, so this package was only written about a month, 2 months ago or so as a community project, and that would be a really interesting piece.
Okay, thank you for that. Gentleman with the baseball cap.
Is there anything similar for Jupyter notebooks?
So this is specifically written to work with our markdown documents, which obviously is an issue at Python comments. But from my understanding, it is being ported into Jupyter. So at the back end, it uses Pandocs. So there's nothing that stops this from working with Python. I don't know how it would work with, say, Julia or the sort of SQL magic that you get in Jupyter notebooks, but from what I understand, it's moving to that, and that is for me, that's the best point for its use, because people use those documents to collaborate effectively all the time. That's good.
Thank you.
So what is it like to write Python in RStudio?
It's the same as writing it in any IDE. I have lots of opinions on IDEs that I won't get into here because someone will hit me when I leave this room. But you basically, people have set up things so that you can just write stuff quite easily. So all you do is change a line to Python, and then it has a Python REPL at the back end that just does everything for you, and you can move between, you can call variables that you write in Python from R, and then vice versa. So I find it interesting because there's things that I know R does better in some respects than Python, and there's a lot of stuff that Python does better than R, and so it's nice to be able to use the two in one place. But then you would get the same functionality in a cheaper notebook, but I don't know how it deals with the handling of moving variables to and fro.
Thank you. We've got time for a couple more questions if there are any. Okay, there may be questions after unless you wanted to.
Yeah, I'll be around until I think just after lunchtime if anyone wants to grab me and ask me any questions or yell at me or whatever.
Let's thank Rich again for his talk this morning.